right, guys, so this video is for Thursday, January the 11th. I know we have a lot of videos this week, but this is a pretty short unit and we will be taking our CBA and that's probably 2 weeks, probably about the 23rd, 24th, I'm guessing. So we started talking last week about expression. So the difference between an expression and an equation is an equal sign. Since this is lacking an equation, an equal sign, it's an expression. As soon as you put that equal to any number, that turns that expression into an equation. These are our standards and our learning targets. So we have this expression. Last week, we also talked about how to determine how many terms are in each expression. We talked about how plus and minus signs separate, or that was probably earlier this week, actually. Plus and minus signs separate terms. So we have two terms here. We have 5x and we have a -3. A number multiplied by the variable is called a coefficient. A letter that represents an unknown value in math is a variable. And finally, a number on its own without being attached to a variable is a constant. So you do need to know the definition of each of these words. And earlier in the week, you should have written down those definitions. Like I said, this is an expression because there's no equal sign. These are our vocabulary definitions. Make sure you know each of these words. These are all examples of different algebraic expressions. And the reason we're calling them algebraic expressions is because we're using variables. So in math, when you add numbers and letters together, that's called algebra. Your parents are very familiar with algebra. They've all taken algebra classes before and probably have either very fond or not so fond memories of algebra. So here we only have one term, which is a +5. Here we have one term in this expression, which is a 1. I'm sorry, it's not a 1, it's an x. This whole thing is a term because there's no plus or minus signs separating any of the parts of this expression. So this is only one term. However, this one has 3 separate terms. They're separated by plus symbols. So 5a squared is one term. 2xy is another term, and the third term is a 3. Now we started talking just Monday, just a little bit about like terms. I told you guys to write down in your notes that like terms, I'm gonna write it again for those of you that did not write it the first time. You do need to know how to determine if terms are like each other. So like terms have the same variable, or there could be more than one variable. So we'll put that S in parentheses, and exponents. Okay, should have written that down earlier this week. So let's look at these examples. So we have 5x squared and negative or minus 9x squared. These are like terms because both terms have an x raised to the power of 2. That makes these like terms. These are non-like terms. They're not like terms because this is 8 is not attached to a variable. This is a constant. This 8 is actually a coefficient because it's being multiplied by y. So they're not like terms. These are both like terms because the variables match and we don't see any exponents, which means the exponents are all the same. They're all ones, okay? These are non-like terms because even though they have the same exponent of 2, the variables are different. So these are unlike terms, Now we have 7y squared and 1/2 y squared. So even though this is a fraction and this is a whole number, these are still like terms because of the y squared and y squared. These are unlike terms because even though they both have x's and y's, because one of them has an exponent of 2 and the other one doesn't, that means they are unlike terms. Okay, we'll talk more about like terms next week when we start combining like terms. So we talked earlier this week about coefficients. Coefficients are numbers multiplied by variables or attached to variables. So in this expression, 1/4 is being multiplied by a variable. So 1/4 is the coefficient. Here we have 16 is the coefficient. In this one term, we have 9 is the coefficient. We also talked about you can never say there is the coefficient is 0, or if it's a variable, there is always a coefficient. If you don't see a number, it's 1, right? So 1 times x is x, which makes the coefficient 1. All right, here we have an expression. Can you please tell me how many terms do you see? How many terms are there? Well, there's 3. We have a positive 3x squared, we have a positive 5x, and we have a minus 2. So that sign belongs to the number directly behind it. What are the coefficients in this expression? How many coefficients do you see? There's 2 coefficients, and what are they? They are 3 and 5. Oops. That was separating each of the terms. The coefficients are 3 and 5. And then the last question is, what is the constant? The constant is minus 2. Remember that sign belongs to whatever number is right behind it. So this is a positive number. If you don't see a sign, it's positive. At the end of the year, we'll start adding and subtracting with positive and negative numbers. So what I want you to do, and I did give you notes to print, so you can do this on your printed notes. 2 things. First of all, you're going to determine how many terms there are in each expression. And the second thing you're going to do is list the coefficients. So I'll give you a minute or 2 and come back and check your answers, I should say. All right, number 1, how many terms are there? There's 3. There's 3 terms. We have a positive 2x, a positive 3x, and a positive 7. The coefficients are 2 and 3. Coefficients are numbers multiplied by variables. Number 2, how many terms do we see? We see 3 terms. And what are the coefficients? They are 6, 12, and 3. Number 3, how many terms are there? So there's 1, 2, 3, 4. There's 4 terms. What are the coefficients? 2 and 10. What are these numbers? What are these called? These are called constants, right? The constants are 4 and minus 2 or negative 2. Number 4, there are 2 terms. And what are the coefficients? Did you say 1 and 8? Forget there's a 1. If you don't see a number, it's a 1. And finally, number 5, how many terms are there? 1, 2, 3, 4. I'm going to box in this just to separate everything. 1, 2, 3, 4, 5, 6 terms. And what are our coefficients? They're 2, 4, 12, and 8. All right, on the last one, let me just ask you one more question. What are our like terms? Number 5, what are our like terms? Let's list them. We have 2a is like 8a. You agree? This and this, those are like terms. What about 3? We have a constant of 3. Is there another constant? Yeah, minus 2. Minus 2. Those are like terms. All constants are like terms. And then finally, we have 4a squared is like 12a squared. Okay, we have 3 pairs of like terms. So, like I said, we'll talk more about like terms next week, but some of you are already ahead of things, right? Now, we're going to start talking about translating algebraic phrases into expressions and the opposite, taking algebraic expressions and turning them into word phrases. So this is a great video on slide 11. I really would like for you guys to watch it just for more examples, because we could do an endless number of examples. Now, you do need to be familiar with all of the words on this list. You need to know that all of these words mean to add, right? If I said, what is the sum of 3 and 5? I am asking you to add 3 and 5 together. You need to know that all of these words mean subtraction. If I said, what's the difference between 20 and 4? I would be asking you to subtract 20 and 4 and get 16. All of these mean to multiply. What is the product of 2 and 3? The product of 2 and 3 is 6. And each of these means to divide. What is the quotient between 18 and 3? I'm asking you to divide 18 by 3. We would get 6. So you need to know all of these words and what they represent. All right, so let's actually, I'm going to skip this slide. I'm going to go to the next one because the order of numbers and words matter. All right, so ignore everything on this page for a second. Let me just tell you something. All right, so if I say, what's 5 plus 3? Is it the same thing as 3 plus 5? Well, of course, both of those have an answer of 8, okay? So addition and also multiplication have a property called the commutative property. If I multiply, I should be multiplication symbol. If I multiply 5 times 3, I'm going to get the same answer as 3 times 5. And this is called the commutative property. Well, there is no commutative property for subtraction and division because 8 minus 3 does not equal the same thing as 3 minus 8. Okay. If you have 8 apples, can you give away 3? Yes, and you have 5 left. If you have 3 apples, can you give away 8? No, that's not possible. 3 minus 8 is actually negative 5. So the order of the numbers for subtraction and division is especially important. Same thing. If I have 20 divided by 4, I would get 5. But is 4 divided by 20? Absolutely not. It's not 5, right? Because remember, you have to put the first number in the box, the second number outside the box. So 4 divided by 20 is actually 0.2. It's very different than 5. If someone owed you $5 and they gave you 20 cents, would you say, oh, it's the same thing? No, of course not. So there's a couple of phrases I want to go over with you where basically you would reverse the order that it's written in words, okay? And those two phrases are more than and less than. Now, more than means addition. So is the order super, super, super important? It's important, but it's not going to change the answer if you add two numbers in a different order. However, less than, if you write an expression incorrectly where they use less than, where you're supposed to show a subtraction problem and you get the order wrong, then you literally have missed that question, because if you turn subtraction problems around, you're going to get different answers. All right, so let's look at a couple of these. So the first one is 5 more than X. So when I say reverse order, what I mean is you take what's in the front and you push it to the back. So 5 more than X. So you're going to take the X and start there. So 5 more than X can only be written this way. That's literally the exact order you would write 5 more than X. Since it's addition, is it super important? It's important, but if I wrote 5 plus X and X plus 5, it's the same answer, technically. However, like I said, subtraction, you must write them in the right order. W less than 20. So since we see the phrase less than, we're going to switch the order that we see them written in the word phrase. So 20 less than W can only be written in this order. That's it. If you wrote W plus 20, I'm going to mark it wrong. It's incorrect. Okay. Are there any more? Did I give you any more? Yes, I did. All right. 6 less than. All right. So let's start there. So when we see less than, we're going to take whatever's in front of it and push it to the back. And of course, less than means subtraction. So we're going to start right here. How do you write the product of 8 and M? Product means multiplication. 8 times M. So if you squish those together, that literally means multiplication. 8M means to multiply. If you used a dot, that would be okay. If you use parentheses, that would be okay. Most often you're going to see 8M, but you're not going to use a variable and an X together. That's very confusing, right? That was like two variables, kind of. Don't do that. So any of these are fine. And then the end of it is going to be -6. Because 6 less than makes 6 jump to the end. I hope you took special note of all of these. All right, now we're going to go back to the original page. The first example. All right, here we go. It's the word phrase of 3 more than a number, more than. They've already used our special phrase, more than, reverse order. So we got to start with T. So T plus 3 is how I would write 3 more than a number. And you can use any variable unless it tells you a specific letter, okay? A number Y decreased by 4. So we're going to find decrease over here. We know it's subtraction. We're going to stay true to the order that we see. The only time we reverse order is if we see more than or less than. That's almost always true, but those are the most popular ones. All right, so Y minus 4. The product of 3 and a number, they don't have a specific letter, so you can use whatever letter you want. The product needs to multiply, so we're going to have 3x, 3a, whatever you want. And then the last one, the quotient of 25 and a number. Since 25 comes first, you must write it first. 25 divided by x, it can look like that, like a fraction, because that represents division, right? Or you can also write it out this way. Both of those are absolutely correct. All right, we've already talked about the next slide. So now here's 8 problems. I asked you to write these out. I mean, no, I didn't. I asked you to print this page out. Excuse me. So I want you guys to pause the video and see if you can figure out exactly how to write each of these. And then I'll go over the answers. All right, number 1. M increased by 5. The increase means to add, so we do M plus 5. All right, what about number 2? Number 2 says 8 less than, so we're going to take that 8 and then push it to the end. So we got to start with x minus 8. Unfortunately, if you wrote 8 minus x, that is wrong. No credit for that one. All right, number 3, a number r divided by 15. So r divided by 15. If you started with 15, you are not correct. So be careful. Both of these are absolutely correct. 27 times the sum of, now when it says the sum of, that means we have to add together what follows. The sum of what? The sum of x and t. The sum of x and t. Now, because of order, oh, and that's confusing too. I don't like using t's with plus symbols. So anyway, we try to avoid that. Obviously, I didn't this time. All right, and then it's 27 times all of this, the sum of x and t. So we must use parentheses. And to show multiplication, we're going to write it like that, or we could do a dot. But if you don't write those parentheses, it's incorrect. Because if you wrote it just like this, order of operation would make you multiply first and then add t, which is not the sum of x and t, right? So not needed. That video I told you about earlier, I got some different examples like this. Those are very important, a little tricky. Number 5, here we have less than. So I take what's in front of the less than, and we'll throw it to the back. So 11 less than what? 4 times the number y. 4 times the number y. So I'm going to start there. 4y. And then 11 less than that. It's written just like that. Just like that. 2 more than. So I'm going to see more than. I'm going to push it to the end. More than means to add. So 2 goes to the end plus 2. Something plus 2. And then what? 2 more than 6 times a number. I can use any variable I want. 6 times a number. And then plus 2 as we written just in that order. So this is 5 times W plus 1/3. So 5W, 5 times W plus 1/3. It doesn't say the sum of W and 1/3. It doesn't say that. So I'm writing exactly what I see in that order. I can leave it like that. I don't have to have parentheses. If this is 5 times the sum of W and the third, I would do it like this. All right, number 8, another way we know about parentheses is if there's a comma. Okay, so anything before the comma is going to be separated from whatever's behind the comma. So we're going to look at this one at a time. W squared, it says plus what? The product of 7 and K. How do I write the product of 7 and K? I'm going to write 7K and all of that plus 5, okay? On this particular one, if I don't have parentheses, it's okay because order of operation would make me just add in order from left to right, but I want to be extra careful, make sure I get full credit. So if I'm ever in doubt, if there's a comma, I'm going to be adding parentheses. All right, guys, I think that's the only ones we had to do today. Oh, no, actually, we're going to do the opposite just for a minute. So then we can take the opposite. We can take a algebraic expression and we can use words to explain what that looks like. Now, there's a ton of different answers, right? So I can't possibly go over all of the answers. But if we have 2 plus x, these are 2 different ways to describe it. Another way would be, you could say x more than 2. The total of 2 and x. 2 increased by x, right? There's lots of different ways. All right, so there's only 4 of these, and this really is the last screen. So I just want you to take a minute, and if you have a friend working with you, especially, I want you guys to see if you can figure out different ways to say these. You got to get the order correct. Let's get it up over. All right, so I'm just going to say some of the answers. So number 1, we could say 3 times x. We could say the product of 3 and x. We could say 3 multiplied by x. That's pretty basic, right? Number 2, we can simply say 8 plus a, 8 plus a number. We could say the sum of 8 and a. We could say a more than 8. We could say 8 increased by a, so on and so forth. Number 3, we could say the product of 2 and x increased by 9, right? We could say 9 more than twice a number. Twice means multiplied by 2. We could say, I don't remember what I just said. The product of 2 and x plus 9. All right, what do you come up with? And then the last one, you could say y less than 2. You can't say 2 less than y, right? Y less than 2. You could say the difference of 2 and y. You could say 2 decreased by y. You could say 2 minus y. All right, so hopefully you got at least 1 or maybe 2 of the ones that I said. All right, guys, I hope you have a wonderful Thursday, and you will have another video for tomorrow. I know lots of videos this week, but lots of learning to do, you guys. So everybody have a good day, and I will talk to you guys later. Bye.